Ernest Rutherford was born on August 30th, 1871, in Nelson, New Zealand. That's only 25 days after my birthday. No big deal. He was the fourth child of 12 and second son of 7. His father was James Rutherford, who immigrated to New Zealand in 1842, and mother Martha Thompson was an English schoolteacher who went to New Zealand in 1855.
It was here in Nelson, New Zealand that he went to Fox Hill School as a child, and then won a scholarship to Nelson College and went there for the following 3 years. He became the head prefect, played rugby, and won a scholarship to attend the University of New Zealand, and later won yet another scholarship which allowed him a return for a master's year. He graduated with a double major in mathematics and physical science.
It was here where he began his research on a Tesla coil, which could transmit power without wires. He later re-enrolled in school so that he could be a candidate for a scholarship. While there, he took geology and chemistry for a bachelor's degree and started his research on the magnetism of iron at high frequencies.
No surprise here, he went on to win his third scholarship, which allowed him to go anywhere in the world and work on research of importance. So, he chose to work with Professor J.J. Thomson from Cambridge University, where he continued his work on detecting electromagnetic waves, and he ended up creating a device which could detect them from several hundred meters.
His interest quickly changed to understanding radioactivity, and in 1898, Rutherford discovered the two separate types of emissions from radioactive atoms, and he ended up naming them alpha and beta rays. Then, in 1900, he married Mary Day Renzi Newton.
He then moved to a university in Montreal, Canada, where he discovered radon and was soon elected a Fellow of the Royal Society of Canada, and shortly thereafter, London. His first book, published in 1904, was titled Radioactivity, and in 1908 was awarded the Nobel Prize in Chemistry for investigations into the disintegration of elements and the chemistry of radioactive substances.
Rutherford's next foray into his science research came after becoming a professor at Manchester University, where he showed that an alpha particle was a helium atom stripped of its electrons. He developed a method of detecting single particles, which he used to determine physical constants such as Avogadro's number, commonly referred to as Avocado's number.
One of his biggest findings, however, came from the discovery that alpha particles could be reflected back by metals. This led to his reasoning that the mass of an atom is concentrated in the nucleus, and the nuclear model of an atom had been created. In 1919, Rutherford became the director of Cambridge University's Cavendish Laboratory.
In 1930, his only daughter, Eileen, died at age 29 of embolism, just after giving birth to her fourth child. This, however, eclipsed his reaching the New Year's Honors List in 1931, which technically made him Ernest Lord Rutherford of Nelson.
After it was discovered by George Gamow that a lower energy would be more efficient in penetrating an atom's nucleus, Rutherford successfully discovered tritium, the third isotope of hydrogen, and an isotope of helium, with the assistance of a low-voltage accelerator. Ernest Rutherford finally died at age 66 on the 19th of October, 1937, from partially strangulated umbilical hernia. Even after his death, he appeared in multiple countries' stamps, and a monument was built at the site of his birth.